Welcome to Chapter 5, the last main chapter in Algebra 2. You've made it this far. We can finish off strong. All right, so this does include 2 lessons. I will probably take the video and do the part that includes lesson 5.1 and then separate it and do 5.2. However, the big ideas practice will include both lessons together. So you will have to have watched 5.1 and 2 to get the practice unlocked. All right, so in this, we're talking about rational exponents. We're going to review or go back to your exponent rules and things that you have learned previously and just add a little bit to it. Hopefully, since we have done chapter 7 with rational functions, hopefully some of this will be a little familiar and will go a little quicker for you. So one of the things I do want to remind you of is what a rational exponent looks like. So previously, I'm trying to figure out where I want to write this. Previously, we've learned that you can have the square root, and we've actually revisited this year. So say you have the square root of a to the nth root of a. So this could be square root, it could be cube root, fourth root, whatever. If there's no number here, there's a 2 because it's a square root. So this is the same as a to the 1 over n. Another way you may have learned it is like this. I think I've done it like this before, where this is the same as, not a, but x to the a over b. So you may see this both ways as we go through this lesson. I think they stick with this for the most part, but just know that it is related to this that you've learned in the past. All right, so let's just get started. Here's a little fun reading for you. And basically it's just talking about what an nth root is. So it's any number. So 5th root, 6th root, 2nd root, any number root. So you can find these on your calculator. It usually has an X right here and you just put in the number that you need. So we are going to be using those today. And so here you have a little table. When n is even and greater than 0, there are 2 real roots. The positive root is called the principal real root. So your a value, so the number underneath the radical, if it's less than 0, there's no real roots because that means it's negative and it's imaginary. All right, if it's equals 0, there's only 1. So this kind of goes back to a previous lesson, 3.4, that we did with quadratic formulas. If your a value is greater than 0, then you have 2 real roots, and the positive one is your principal root. All right, so what does that mean? Well, we're just going to practice finding the indicated root. All right, we're just going to practice finding the indicated root. So in this, we're using this format. All right, so we're going to plug in the a under the radical, the n comes out here. So we're going to have the cube root of negative 216, and we're going to find the real root. Now, because negative 216 can be written, so this is odd, right? So that was when they were even. I forgot to go over the odd ones. When they are odd and you have less than 0, then you have 1 real root, and I'm going to show you why in just a minute. If it equals 0, you have 1 real root, and if it's greater than 0, you have 1 real root. So if your number on the outside of your radical is odd, you have 1 real root for all of them. So the only ones that change is if it's even. And that's because of your negative property. So what we know is that negative 6 to the 3rd power is equal to negative 216. Okay, so because of that, then I actually can solve this. I wanted to bring out the calculator too, so that way you would know how to use it on here. So you're going to hit our favorite button, the math button. And if you notice, right here is the cube root. So if you just need 3, you can always do that one, but any number you need, you can do 5. Okay, this one though, you would have to put the number in before you hit this. So I'll do an example of that in just a minute. So for now, I'm going to hit number 4, and I'm going to find the cube root of negative 216. And hit enter, and it gives me negative 6. So you can put these right in the calculator. All right, so this next one, part B, our n value is 4. So we're basically saying what number can we multiply to itself 4 times that would give us 81. All right, but I want to show you how to do this one in the calculator as well. So because it's not square root or cube root, we're going to type in the 4 first, and then we're going to go down to number 5. Now, notice how it put my 4 right there. You have to put the number in first. And then 81, and then hit enter, and they said the answer is 3. So how do we know that? Because 3 to the 4th power is equal to 81. All right, so not too bad, not too bad. I want you to try a couple. I'm going to self-assessments just to give it a try. If you don't have the calculator, you can always, these are all even ones, so you really don't just think of a number that you could multiply. So pause now and please give these a try. I'll go over the self-assessments in just a moment. I did forget to do positive or negative for this. I just realized this as I was going through the self-assessments. So remember, there was 2 real roots if it's even and greater than 0, so it should be plus or minus 3. So what the reason is because even negative 3 to the 4th power is also 81. So I apologize for that. I'm going to go back to the self-assessments now. Okay, so hopefully you gave these a try. This one we have learned in the past. Now in this lesson, it doesn't talk about i's yet, but just to refresh, remember we did learn in the past that that would be equivalent to 7i. But in this situation, we would say there's no real square roots because technically that is imaginary. And it would be plus or minus 7i. All right, so make sure you did your plus or minus with your evens, your odds. You didn't have to. So the only one that was a little different was number 2. So hopefully you gave it a try. All right, moving on. We're going to talk about rational exponents. And we're going to just be rewriting them. So what I'm doing, in a moment, I'm getting from this table. All right, but to fit it on the paper, I just didn't do it on that one. So there's 2 ways you can do these: rational exponent form and radical form. You can choose the way that you like. I personally like one better than the other, but it is completely up to you and what you understand the best. So I'm going to show you both options so you have both options when doing it. Okay, so basically this was just doing it in exponent form. This one's doing it in radical form. And the way that we're doing this is very similar, and so that's why I personally just like doing one way more than the other. I'm not going to tell you which one that is because I don't want you to be biased and do it the way I like. All right, so I can rewrite this. We've done this in a previous lesson where I see the halves, and I know anything to the half power is the same as the square root, right? And so I can think about this as what number to the half power. So anything to the half power would be what number times itself. So we have 4, and then that is what 16 and 1/2 is equal to. And then we can put that to the 3rd power, that equals 64. So maybe this way of thinking is a little odd. All right, so another way you can do it is using radical form. And so we can take that 16 and 3/2, and instead of writing it as 16 to the 1/2 power, you could rewrite it like this. So the square root of 16 to the 3rd power. We know the square root of 16 is 4, and then 4/3 is 64. So either way you get the same answer. It's just, do you like exponents or do you like radicals? Maybe you like neither. This is supposed to be a negative sign. I tried to fix it multiple times, but it just didn't like me. So this is the same as 32 to the negative 3/2. I just finally gave up because it just wouldn't let me fix it. All right, so same idea. We could do a rational exponent form. I see this has a denominator of 5, so that's how I'm going to separate it. But first I need to deal with this negative. All right, so remember, we know our negative rules. We can put this over as a fraction to make our denominator positive. All right, so now what I'm going to do is separate this by taking the 3 to the outside, leaving the 1/5 inside. So I have 32 to the 1/5 power raised to the 3rd power. So 32 to the 1/5 power is the same as saying what number could I multiply to itself 5 times and get 32, and that would be 2. So this is the same as 1 over 2/3, which is the same as 1 over 8. So if you like the exponent way, this is the way to go. If you like the radical form, so the same idea, I got to move it to the denominator. But instead of doing the power of the exponent rule, I'm going to do it a radical. So what I'm going to do is, well, try not to break my pencil, is I'm going to put it over 32, but I'm taking the 5th root, because remember, denominator, 5th root, and that is going to be raised to the numerator, which is 3. So now if you put in your calculator what is the 5th root of 32, you would get 2. And so you would still have the same thing, 1 over 2 to the 3rd power, which is 1 over 8. All right, so please don't let this confuse you that I did multiple ways. You get to choose your way. I'm not telling you which one is my favorite, but you may have figured it out. I do want you to try some without, we're going to learn how to do this with technology, but just so you have the understanding, I would like for you to try these without technology. So doing the same thing that we just did. So please pause, give those a try now. Okay, so I did both ways. All right, over here I did it doing the exponential way. Over here I did it doing the radical way. So if you would like to see both with both of these to try and figure out which one you like best, just let me know and I will work with you. All right, so now we're going to do it using technology. Yay, because we love technology. All right, so it says we are going to approximate expressions with rational exponents, evaluate using technology, round your answer to 2 decimal places. All right, so to hundreds. So how do we do this? Very simple. All right, we're going to type in a 9. All right, and I have an exponent, so I need the exponent button, which is this up arrow here. So now I have it raised up, but I have a fraction. So see the green part right here, if you don't already know this, that gives you a fraction. So I'm going to hit that. I'm going to do 1. You arrow down to the denominator, put in 5, hit enter, and voila. I have a beautiful answer of 1.55184, blah, blah, blah. So they said round 2 places, so that's this place. So I'm going to look at my 1. My 1 is 4 or less, so I'm going to let it rest. So this is approximately 1.55. All right, not too bad. So let's try another one. We're going to do B. So I'm going to type in 12, hit my exponent up button, and then I need a fraction. So I'm hitting the green button, then the fraction button, the 3, arrow down to the 8, hit enter. And now this one, I got 5, 3, but my 9 is 5 or more. So that means I'm going to round this to 4. So this becomes approximately 2.5. Stop pressing down so hard. 2.54. Sorry if y'all hear my dogs barking. People are walking down the street. Don't know why they're doing that. All right, so this one's a little different. I was trying to move there we go. This one's a little different. If you want to write it in this form, you are welcome to, but you don't have to. So what we can do is we can put this in. So I'm going to hit my math button. Well, before I hit the math button, remember if it's greater than 3, you have to put the number. So I'm going to put 4. Then I'm going to hit my math button and scroll down to number 5 and hit enter. And so then I'm going to put 7 inside. All right, this is the important part. You got to scroll out. Don't put it inside. If you put it inside, it's going to give you a different answer. You have to scroll out. And we're going to cube it. So raise it to the 3rd power. And there we go. Nope. See how it put it back inside? We don't want that. So let me show you the difference. We're going to use parentheses. All right, we're going to hit the 4 first. Then we're going to go to our math button, scroll down to 5, put in our 7, put in our, don't want the parentheses there. Where's delete button? All right, arrow out, parentheses. Now I'm going to raise it to the 3rd power. Gave us the same answer. That's interesting. So I guess it doesn't matter the way that you did. I don't know why I didn't think about that, but interesting. So we're going to round it to 2 decimal places. Well, at least now you know it doesn't matter. Our second place is 0. The 3 tells us to keep it. It's not necessary to write a 0. I mean, if you want to, you can, but this is the same as 4.3. Okay. So if you have a calculator handy, or you want to go to like Desmos or something and do it on there, you are welcome to try these. If you want to wait till you get into class, write these down, and then you grab a calculator and make sure you understand how to do these. That would be great as well. So please pause now to write them down or to give them a try. All right, so here are your answers. Notice this one is equal because it actually gives us a whole number, so we don't have to round it. So rounding, you use the approximate. Not rounding, you don't have to. All right, so let's move on. I do have an extra credit opportunity for you. Please write it on a separate sheet of paper. You can even do it a sticky note, turn the sticky note into me. Just don't show it to me when you're showing me your notes, because I need a chance to be able to put it in the grade book. So if you would like to give this a try, which expression does not belong with the other three, you must explain your reasoning why. All right, it must be a good reason, not just because you said so. All right, so extra credit opportunity. All right, so now we're going to solve equations. We've done something similar to this in the past, but now we're going to do it with something larger than the, can't find my words, I apologize, larger than square or cube, okay? So what are we going to do? We're going to divide both sides by 4. So when I do that, I am left with x to the 5th power is equal to 32. All right, so now from here, what we're going to do is take the 5th root. So before we would take the square root. So this time we're going to take the 5th root of both sides. So what happens here is these cancel each other out. We're left with x. And you can put this in the calculator, but hopefully by now you've learned that 2 to the 5th power is 32. So it is odd, so it would just be 2. If it was even, remember you can have more than one solution. Okay? So our solution is x equals 2. All right, so now this one's slightly different. The only difference is that we have something inside parentheses. So what we're going to have to do first is get rid of the 4 that is the exponent to the parentheses. So we're going to do that part first. So how do we do that? We take the 4th root of both sides. So we end up with x minus 3, because remember this cancels that out. And we have equals the 4th root of 21. There is no number times itself 4 times that equals 21, so we're just going to leave it like that. Now, because this is even, we're also going to put in a plus or minus. So now what do we need to do? We need to move the 3 to the other side by adding it. So x is equal to 3 plus or minus the 4th root of 21. Hopefully this brings back some memories, because we have done something similar to this in chapter 4. So if you have a factor in here that you could find the 4th root of, you could simplify it. In this case, we don't. So that's as far as we can go. All right, so I want you guys to try these. All right, at least 16 and 18 at the very minimum. Challenge yourself, try the other two. They don't take that long. You saw they didn't take very long. And then we will come back and look at the answers. Okay, so if you left this one in the cube root of negative 14, that's fine. In Big Ideas, they did simplify this. They did it in the previous one as well. I just didn't catch that. So what I'm talking about is, in this one, they actually worked out. They said the 4th root of 21 is approximately... excuse me. I don't know. They didn't give that to me. Hold on. Minus 2.14, because remember we have plus or minus. So then x is approximately 5.14. X is approximately, what does that equal? 0.86. All right, so actually these were the solutions. I didn't read the directions. So shame on you, Miss Gill. So round your answer to 2 decimal places. That's your clue if you're going to simplify into decimal. If it doesn't say that, if it just says simplify as simplified, then you would leave it this. So this is simplified. This is rounding 2 decimal places. So my apologies. All right, so here you go. If you want to check your answers, see how you did. If you're just writing them down, shame on you. That's done absolutely nothing for you. But this lesson does have a lot of examples. So I would like to move on so we can, actually, I think we might almost be done. Let me see where we're at. Maybe I'm getting a little ahead of myself. So that is it for 5.1. As you can see, property of rational exponents, that is going to start 5.2. So I'm going to stop this video now, and then I will come back. You will see me again or hear my voice again in lesson 5.2. Okay, thanks for playing along. All right, see you in class.